Why are deep reinforcement learning models hard to interpret? Imagine trying to understand how a robot makes decisions in a complex game or a self-driving car navigates busy streets. It's not always clear what's happening inside these systems. That's because deep reinforcement learning models are tough to interpret. These models learn by trial and error, using reward signals to improve their actions over time. But unlike simple programs, they develop very complicated internal processes. One big reason they are hard to understand is overfitting. These models focus intensely on their specific environment, like mastering one game or task. They get so good at that particular thing that they start recognizing weird patterns or quirks in the data. When you try to see why they made a certain choice, it often looks like they are responding to strange clues rather than logical rules. It's like trying to figure out why someone made a decision based on a secret code only they understand. Another challenge is that these models don't transfer their knowledge well. If you train a reinforcement learning system to play one game, it usually can't use what it learned to play a different game. This makes it hard to see what general skills or principles the model has learned. Instead, it's mostly memorizing specific tricks for that one task. This lack of transfer makes the decision process even more mysterious because it's tied tightly to the exact environment it was trained in. Deep reinforcement learning models also operate through complex relationships between states and actions. They use deep neural networks, which are like black boxes. These networks process information through many layers of math, making it nearly impossible to trace how a decision was made. Even if you see the action chosen, understanding why it was selected involves navigating through a maze of abstract calculations. It's like trying to follow a secret recipe that has hundreds of ingredients mixed in complicated ways. When reinforcement learning is used in language understanding or other areas needing context, the interpretability problem gets worse. These models often handle ambiguity or cultural references by recognizing patterns, but they don't really explain their reasoning. They perform well, but the way they arrive at their decisions remains hidden. It's like a person giving a correct answer but not knowing how they arrived at it. Unlike some machine learning systems designed with explainability in mind, deep reinforcement learning models are built purely for performance. They learn through trial and error, guided by reward signals, not by producing explanations. This makes it hard to understand their decisions in a way humans can easily follow. This becomes a big issue in critical areas like healthcare, autonomous driving, or finance. When these systems make decisions that impact lives, it's important to know why they chose a certain action. If we can't interpret their reasoning, it's difficult to trust them or meet regulatory standards. Not being able to explain why a model acted a certain way raises ethical concerns and limits their practical use in sensitive fields. Researchers are working on making deep reinforcement learning more transparent. They are developing methods to peek inside these models and understand their decision-making process better. But it's a tough problem, and there's still a lot of work to do. As these models become more common, solving the interpretability puzzle will be key to making AI systems safer and more trustworthy for everyone.